Hello students, today in your geometry class, we're going to be working on some algebraic reasoning and proofs. So at the end of this lesson, you should be able to solve basic proofs. So, quick warm-up, write the biconditional statement as two conditional statements. 2. Prove each statement is false with a counterexample. This would be a really good time for you to pause your screen. Hopefully you paused your screen and you're now just coming to check your answers. So for number 1, the two biconditional statements are if an integer is divisible by 100, then its last two digits are zeros. Okay, so that's the first one. The next one is the converse. So if its last two digits are zeros, then the integer is divisible by 100. Done. Number 2, prove each statement is false with a counterexample. So remember, a counterexample is an example that proves something false. For example, if I were to say, it's raining in San Diego, then your counterexample could be, it's not raining because the ground is dry or the floor is dry outside. So odd integers less than 10 are prime is the statement. So odd integers less than 10 are prime. So if you think of the odd integers, well, 5 is prime, 3 is prime, 7 is prime, but 9 is an odd integer, and that's not prime. So 9 is not prime because 3 is a factor, would be your counterexample. So what I need for you to do is write these properties down in your notes. Hopefully you've paused your screen and we're now just going through and explaining them. Addition property should be fairly simple. We take two statements, if A equals B, then A plus C equals B plus C. We're just adding that C. Same thing with subtraction, same thing with multiplication and division. Reflexive property, however, is one that's going to be really important as we continue on through geometry. Reflexive property is just like when you look in the mirror, it shows a reflection. It says that if I looked in the mirror, I would see the same thing. If I took my phone and put it in front of the mirror, I would still see my same exact phone, exactly the same size. Symmetric means that we can it's kind of like a commutative property with the equal sign, if you will. It says that if A equals B, then B is also equal to A. Transitive property states that if A equals B and B equals C, then A equals C. So to illustrate that a little bit more, we're going to say A equals B, B equals C. Now you notice that here are the two statements. However, if I were to overlap them, since they're both equal to B, couldn't you then knock out the middleman or the B and say that, well, then A is equal to C? That's the transitive property. Substitution property means that we can take a value and replace it or substitute it. So if A equals B, then B can replace A in any expression. The next one is the distributive property, which states that A times the quantity B plus C is equal to AB plus AC. Properties of congruence, same idea for reflexive, symmetric, and transitive. These are just referring to angles and line segments themselves, not necessarily their measurements. So we're going to do a couple quick proofs. Now here, they're giving us 5 times the quantity x plus 3 equals -4, and that was given. And then we're just supposed to justify the next steps. So you'll see in A, we use the distributive property because we had 5 outside of the quantity, x plus 3, and then we distributed it. B, you'll notice that we got rid of 15 and all of a sudden -4 became -19. So that's actually the subtraction property. Notice that we're just taking what we're doing and we're adding property to the end to make this easier. So from 5x equals negative 19 to all of a sudden having x equals negative 19/5, in order for us to have gotten there, we had to divide 5 to both sides, or we use the division property. So the next set is just to justify the property. So in number 6, you see that we distributed. In the next one, or 8, it says that if ST is congruent to QR, then QR is congruent to line segment ST. That's the symmetric property. Number 10, it's XY equals XY, which is a reflection, or a reflexive property. If KL equals MN, then MN equals KL. Again, that is the symmetric property. And the last one, if AB minus BC equals 12, then AB equals 12 plus BC. That's just the addition property. So for example 1, given 5 times the quantity x minus 2 equals 2x plus 8, we're supposed to prove that x equals 6. So this is our first real intro to a proof, and we're going to use what's called a 2-column proof, which is what you see on the right. 2 columns, one with a statement, one with a reason. Now, to make this the easiest possible, our first statement and reason are the easiest, which is why if you get this wrong, we have a lot of work to do. Your statement is always going to be your first part of the given. So in this place, this was given, and the only reason why we know that, or the reason why we know that, is because it was given. Now sometimes these look a lot more confusing than they need to be. The best way to approach these is just to solve it as if it were just a normal math problem. So in this case, what would we do first? We would first distribute that 5. Then we would subtract 2x from both sides. So we have 3x minus 10 equals 8. Then we add 10 to both sides. We get 3x equals 18. Divide 6 to both sides, divide 3 to both sides. And we get x equals 6. Now, notice we solved it by hand. It was easy. When we do 2-column proofs, it should be that easy. We're going to number our statement, number our reason. I think we might have 3 or 4. So let's just label those now. So, the first thing that we did is we distributed. So notice I'm going to highlight after we distributed and copy that in. That property was the distributive property. Second thing we did, and notice for the statements, I'm not showing the work, I'm just lining up what each line would look like. And the way we got from here to here is because we used the subtraction property. Because we subtracted 2x to both sides. Next thing we did is to get from line 3 to line 4, we use the addition property. And last but not least, we ended up with x equals 6. Now the reason why we got x equals 6, if you notice from the statements from 4 to 5, 3x equals 18 became x equals 6. And the way we got that was we divided. So we divided by 3, so we use the division property. And that's it. Now it's your turn. Try solving these 3 problems and writing them down in your notes. That's all for now. I'll see you guys next time.